Alright, so we're going to start the new chapter and we're going to actually do 2 lessons in one today. So we're actually going to do lesson 3.1 and lessons 3.2. Now, in chapter 3, it's all about inequalities. Chapter 2 was all about equations. The good news though is they're almost identical. Okay, with equations, you are solving multi-step equations, two-step equations, variables on both sides, absolute value equations. We're going to do all those same things except with inequalities. We'll have inequalities with variables on both sides. We'll have multi-step inequalities. We'll have absolute value inequalities. And so you're going to see a lot of the similar things. Okay. Now for today, I'm actually going to do 3.1 and 3.2 together. Why? Because 3.1, this lesson, this first one, you did as a 7th grader last year. You have this exact lesson almost identical in your 7th grade book. So I'm going to go through this one quickly and then I'm going to spend a little more time on 3.2. So in your notes today it's going to be a little weird. So we're going to start off with 3.1. So go ahead and title it 3.1 Graphing and Writing Inequalities. Okay, and then we're going to go from here. So really quickly, vocabulary. Okay, you don't have to get any of this down. You should already know this. An inequality is a statement that when two things are not equal, right? That's why it's inequality. If it's an equality, it would have been an equation, right? Now, this is the tricky part. The solution of an inequality is any value that makes it true. Okay? Now, you remember when we solved those equations back in chapter 2 where we had like all real numbers or we had no solutions? And remember with the all real numbers we could put in any number and it would work? Inequalities are kind of like that. Not fully, but just a little bit like that. Because there's more than one answer for these guys. That's why we graph them. And very quickly, here are your inequalities. Less than, greater than, less than or equal to, greater than or equal to, or not equal to. We're not really going to use this that much. We're really going to focus on these 4. This will come in later when we get to our special cases. So, really quickly, graphing inequalities. Now, inequalities have too many solutions. Okay, it's not like an equation where we can just say, oh, x equals 7, x equals 9. Inequalities are much different. So what we do is we write the inequality and then we do a graph. So here's what I want you to write down. Right here what's in this blue box and then highlight it. So if you will have an open circle on your graph if you have either of these inequalities, a less than or a greater than. What it means is the endpoint is not a solution. You will have a solid circle or closed endpoint, which means the endpoint is a solution if you have less than or equal to or greater than or equal to. So this is the only thing you need on this slide here. So go ahead and pause the video. You have 1 minute. Okay, now that you have this down, I'm actually going to get out of that mode so I can show you this. So here's what some of your graphs are going to look like. So let's say we got an answer of x less than 5. 5 is where we put our endpoint. Notice it's open circle because look at the inequality. It's less than. It's not equal to. And when it's less than, the endpoint is not a solution and it's an open circle. And notice it's x less than 5. So it's everything smaller or to the left of 5. Look at this one. X is greater than -1. So it's greater than, so the endpoint is not a solution, so it's an open circle on -1. And x is greater than that. So that's all the numbers bigger than -1. So we would go draw the arrow to the right. Now, here's another example. X is less than or equal to +1/2. Now, less than or equal to, since it has that equal to, that means the endpoint is also a solution, so it's a closed circle or solid. So we would put a solid circle, and it's less than or equal to, so it's everything to the left. And right here, this is x greater than or equal to 0. So we would have a closed circle on 0 and everything to the right. So these are some examples on what you're going to be doing in this chapter. So let's actually practice writing some basic inequalities. That's all we're doing in 3.1. So first example. Now we're just going to use x as our variable. Technically you can use any variable you want, but let's just keep it simple and stick with x. So we would say x. Now, does everybody see it goes to the left? So these are all the numbers smaller than 2. So I know it's going to be a less than. Since this is an open circle, that means I cannot use that number 2. So there's no equal sign. And since the endpoint is on 2, I write 2. So that's it. So this is the graph for x less than 2. So let's look at the next one, b. So here's our first example, by the way. So if you don't remember this, you would draw this inequality and then write your answer down. So now here, again, we're going to use x. Now, this time it's a closed circle. You see that? So I know it's an equal sign. So I'm going to put my equal sign there. Now, it's everything bigger. Do you see that as we go to the right, it's getting bigger? So it's going to be a greater than. And the endpoint is on negative 0.5. So that's how I would write that. Just like that. Okay, hopefully you're remembering this. I'm not joking. You did do this last year. Okay? All right, let's move on. This is just the explanation. Okay, you have 1 minute. I want you to actually graph these. You have 1 minute. Get as many done as these as you can. So go ahead and pause the video and start your timer. Okay, now that you've gotten a chance to do these, I'm actually going to do them right now. Okay, so first things first. First one, b less than negative 1.5. Okay, so see how it's less than? It's not, oh, so it's an open circle. That's negative 1.5, so that's between negative 1 and negative 2. So I'm going to put it right here, open circle. And it's less than, so I'm going to shade to the left and I'm going to draw an arrow. That's it. All right, next one, r greater than or equal to 2 squared minus 4. Well, I have to simplify this first. So this is r greater, well, 2 squared is 4. 4 minus 4 is just 0. So this is really r greater than or equal to 0. Now it's equal to, so it's closed circle, it's on 0, and it's greater than, so it goes to the right. Next one, m is less than or equal to 3/4. Well, 3/4 is like 0.75, so it's just a little bit less than 1. So here's 1, so I'm actually going to put it right about here, and it's a closed circle because it's equal to, and since it's less than, it points to the left, so I'm going to go to the left. And the bottom one isn't showing, so it's t greater than or equal to, okay, so what I would do here is this is actually 2. 2 times 2 is 4. So I would get t greater than 4. So I'm actually, let me just write it here, t greater than 4. So I'll just graph it up here, see how it's cutting it off. So t greater than 4, so that'd be open circle on 4, and since it's greater than, it goes to the right. And that's it. Okay? Alrighty. Let's go on. Okay. Writing again some more inequalities practice. So go ahead and try both of these on your own. You have 1 minute. Pause the video. Okay, let's actually do these real quick. Now, this is the first example I did earlier, so I'm just going to use x as my variable, x. So my endpoint is on 3, and it's a closed circle, so it's equal to, and it's everything to the right, so it's greater than. That's it. Next one. Again, I'm going to use x. My endpoint's on negative 5.5, and it goes to the left. So it's a less than, and since it's an open circle, it's not equal to. So that's my inequality. Okay? Alrighty. Moving right along. So basically that's it. We're actually done with 3.1. So in your notes, go ahead and draw a line, or if you want to do a new page, that's fine. Your choice. We're actually now going to do 3.2, and then the next series I'll do 3.3 another day. So 3.2, this is where we're going to do a little more work. So 3.2, one-step inequalities using addition and subtraction. So remember, equivalent inequalities are inequalities with the same solution set. Now, we're going to be solving. So remember, when you solve, you want to isolate your variable. You want to balance both sides by doing whatever you do on one side, you do it on the other. Always perform the same operation on both sides, and then make sure you use your inverse operations, okay? Now, this is called set notation. We're not going to use set notation, but I just want to kind of expose it to you because you do use it later on. This basically says the set, it says it right here, the set of all numbers x such that x is less than 6 in this case. Okay, you don't have to write this part when your answers. You're actually just going to write this part. If you want to actually do this and get in that habit, now for those of you that are going to take pre-calc and calculator, algebra 2 and all that stuff, go ahead and do that. That's fine. That's an advanced level step. You can do that, but you don't have to. Okay, now here's your properties. Basically, you don't have to get these down because you actually already wrote these down with the equations. It's basically the same thing with inequalities. All this says with addition is whatever you do to the one side, you do the other. With subtraction, whatever you do to the one side, do the other. Okay? Moving right along. Okay, here's our 3 examples. So we're going to do all 3. So we'll start with the first one, and I'm literally just going to go in columns. So solve these just like equations. So here's our first example, x plus 9 less than 15. So think of the inequality as your equal sign. So x plus 9, so we would minus 9, minus 9. 15 minus 9, 6. So I get x less than 6. And then we graph it. Now let me show you a real quick easy way to do your graphs. X is less than 6. So I know my endpoint's on 6, right? So I'm going to put 6 in the middle. I'm going to do one number to the right, one number to the left, and then I'm going to do my graph. It's less than, so it's open circle, and I'm going to go to the left. That's it. That's all you have to do. You do not have to start at 0. You don't have to start at 10. None of that. I want you to just make it really simple. There's the first one. It's just like an equation. Okay. All right. Let's do the next one. Okay. D minus 3 is greater than negative 6. So we're going to plus 3. Remember, we're isolating our variable. Negative 6 plus 3 is negative 3. So we get D greater than negative 3. So we're going to do our graph. Again, put your endpoint in the middle. Now be very careful with negatives. If I go to the left, I should be getting smaller, right? Which means this should be a negative 4. If I go to the right, I should be getting bigger, which means closer to 0, which means this should be a negative 2. I get students mix that up all the time, and I will mark you wrong if you do that backwards. So D greater than negative 3. So open circle on negative 3. Greater than means going this way. Okay. Alrighty. Last one, decimal time. Now, if you want to clear the decimals, you can. In this case, I personally believe these decimals are really small or really simple, so let's leave them alone. Now this one's going to be a little bit special, so go ahead and put little stars around it. Okay, maybe you can already figure out why. It's because the end's on the other side. So I'm going to do a little trick here. So actually, let me clear my screen. Okay, and now this way I'm going to do I'll have my space over here. So I'm going to put my little stars back. Okay. Now we're going to solve it just like we did all the others, even though n's on this side. This time what I'm going to do is I'm going to move the 0.4 over here. It's minus, so I'm going to add it. Here I get 1.1. So I get 1.1, or 1 1/10 is greater than n. Now, listen very, very carefully. I want my variable first, just like I did here. My variable was first here, my variable was first here. I want my variable first. In this case, the number is first. So, remember in chapter 2, we can flip these, right? But this is not an equation. What do you think we have to do if we rearrange these two here? What do you think we have to do with the inequality? We have to also flip our inequality because these are not equal. Okay, this says 1.1 is greater than n. So if I flip it, I still have to show that n is smaller or less than 1.1. Okay, that's what makes this guy special. So when your variable's on the other side, once you solve it, you can flip them, but you must also flip your inequality. If you don't do that, your answer is wrong. I will mark you wrong. Now, how do you do decimals on a number line? It's this simple. Again, start with what you have right in the middle. Now, you see how it's 0.1 there? If I go to the right, I can just do 1.2. To the left, I would get 1.0. So, it's less than, so open circle to the left. Okay? So, these are single-step inequalities. And just like we did single-step equations, we solve them the same way, except our answers are different. Notice in every single answer, we had the solution set, or we had the solution and its graph. We have the solution and its graph. We have the solution and its graph. You get the idea? All your homework, you're doing a solution and a graph. Okay? It's basically like that for the entire chapter. Expect it. I think it's like every single problem. Okay? Alrighty. Oh yeah, and then here's the little graphs. Okay. So let's go ahead. Now, here's how you can check your answer. Okay, basically you want to check the endpoint. Now when you actually check the endpoint, okay, so when you're actually checking the endpoint, it's an equals sign and it should work. When you're checking the inequality, you want to make sure the statement is true. So what I'm going to do, okay, is in the next example here, what we're going to do is I'm going to actually, let's go back. Let's go back and actually check and show what I mean by these things here. So when we solve this first one, here we got x. When we solve this, we got x less than 6, right? Okay, now watch what happens when I put 6 into here. It says 6 plus 9 less than 15. 6 plus 9 is 15. Is 15 less than 15? No, they're equal to, right? But you see how the inequality is less than? That's why 6 doesn't work. What this says is I can take any of these numbers right here. So 4, 2, I could put 1, I could do negative 7. Any of those numbers will work here. So let's pick right here, which would be negative 1. So if I put negative 1 in there, that would say negative 1 plus 9 is less than 15. Well, negative 1 plus 9 is 8. Is 8 less than 15? Yes. You could try another one. Try negative 10. Negative 10 plus 9 less than 15. Negative 10 plus 9 is negative 1. Is negative 1 less than 15? Yes. Now, see on this side? This means none of these are answers. See how it's an open circle? 6 is not an answer. We already showed that right here. It doesn't work. Well, what happens if you try one of these? Let's try 8. So 8 plus 9 less than 15. That says 17 is less than 15. Well, that's not true. 17 is greater than 15. See, so that's what we're doing here. We're basically figuring out what are all the possible solutions, okay? So now we can move on to our second example. Actually, we're not going to do the practice. We're going to move on from that. Okay, we're going to do 2 word problems. Here's the first one. I'll give you about 1 minute to write down as much of this as you can, so go ahead and pause. Okay, so here we go. It says the memory in Tanea's camera phone holds up to 20 pictures. Tanea has already taken 16 pictures. Write, solve, and graph an inequality to show how many more pictures Tanea can make. Okay, or could take, excuse me. So it holds up to 20 pictures. She's already taken 16. Now there's 3 parts. You see this? Write, solve, and graph an inequality to show how many more pictures can she take. Alright, so we're talking about pictures. So let P equal number of pics, so our number of pictures, okay? Now, we know she's already taken 16, right? Now, some of you are already figuring out, oh, well, you know, she only has 4 pictures left. Well, technically that's true, but there's actually other answers, not just that, okay? Here's what we have to do. We have to write the inequality. So what we do is we say the number of pics remaining plus what she's already taken, which is 16. Okay, and you know the total is 20, right? So that goes at the end. The question is, what's my inequality? It says it holds up to 20 pictures. So does that mean it can actually hold 20 pictures? Yes, so that makes it equal to. But since it can only go up to 20 pictures, that's a maximum. So our inequality is less than or equal to, because it's anything less than 20. And it could be equal to 20. So here's our inequality. So we solve it. Minus, and we get 4. So we get P less than or equal to 4. Now, step 1, write the inequality. There it is. Step 2, solve it. There it is. Step 3, graph it. Four, 3, 5. Now in this case, now this one's a little bit weird. I'm going to adjust this slightly. Now you remember how in our other number lines I just said put the number in the middle and then you just show one number on the right, one number on the left. In this case, now let's think about this. This says the number of pics is less than or equal to 4. So we could do 4. She could take 4 pictures. She could take 3 pictures. She could take 2 pictures. She could take 1 picture. Or she could take no pictures. Now, does it make sense to keep going and say she could take -1 pictures? Or -2 pictures? Or anything like that? No. So in this case, we can be a little more specific on our graph. And say it's 4 to 0. Okay. If you want to just do 4, 3, 5 and do it like this, that's okay too. But you know, if you want to be a little more specific, you can do that one. Okay. All right, let's do another word problem. Okay, so you have 1 minute to write it down. Okay, so it says Josh can bench press 220 pounds. He wants to bench press at least 250 pounds, so he has a goal. Write and solve an inequality to determine how many more pounds Josh must lift to reach his goal. And then it says check your answer, so we're going to check. Okay, so we're going to we'll use the same variable again, P, but this time will be represent number of pounds. Okay. Now, he can already do 220 pounds. So we're going to say 220 pounds plus. The question is how many more does he need to lift to get at least? Now, if it's at least, that's a minimum. So we can equal 250. Come here. We can let it equal 250, but if it's at least, we want it to be greater than 250. Okay, we want it at least to be 250 or bigger, because that's right, because that's his goal. He wants to do at least 250 pounds. So we go ahead and we solve this. So we minus 220, and we get 30. So we get P greater than or equal to 30. Okay, so what this means is how many more pounds must he lift to reach his goal? He must lift at least 30 pounds more. So now check your answer. So to check, notice it didn't tell us to graph, so we don't have to graph. So we check it. So we would put in 30 in for P. So we have 220 plus 30 greater than or equal to 250. Well, 220 plus 30 is 250. Now be very careful here. Is 250 greater than or equal to 250? Now, do you see how there's an inequality here that's greater than or equal to? There's two conditions. This number can either be bigger than this number, or this number can be equal to this number. It's one or the other. It's never both. It's impossible to do both. So is 250 greater than or equal to 250? Yes. So it works. Okay. So that's basically it for our notes. That's all we're doing for 3.1 and 3.2. So 3.1 was all about writing them and graphing them. 3.2 is your first introduction to actually solving them. So what are you actually going to be doing? You're going to be doing your practice out of your workbook. You're doing 3.1 and 3.2. 3.1 and 3.2. This is your homework. It's due the next day, so these are front and back. This is what you're working on. Okay, you do have some word problems here. See how they give you number lines? Make sure you do your values and number lines and so on, and make sure you use your notes. Okay, and this video will be posted online if you need it. Good luck.